Good evening. I'm going to explain how I chose to solve question number 45 in our book, Viewing an Angle. I'll read the question first. The bottom of a large theater screen is 3 feet above your eye level, and the top of the screen is 10 feet above your eye level. Assume you walk away from the screen, perpendicular to the screen, at a rate of 3 feet per second. While looking at the screen, what is the rate of change of the viewing angle theta when you are 30 feet from the wall on which the screen hangs, assuming the floor is flat? See figure. There is a figure, but I actually chose to draw out a triangle, and this looks even, but it is not. So what we're trying to find is how the angle changes. And so what we're going to look at is first let A equal the angle between the line of sight top to bottom of the screen. And when we look at our picture here, we're trying to find the angle that is cotangent, which is cosine over sine, or if you're using Cartesian system, x over y on the unit circle. So for A, it'd be cotangent A of x over 3. And for our second angle, it'd be cotangent A plus theta equals x over 10. Because we're 3 feet off the ground at the bottom and 10 feet off the ground on the top, but we don't know x yet. So what we want to do with this is solve for our angle theta. And what we're going to do, so cotangent A equals x over 3, where you're going to use inverse cotangent to switch to the other side, and A will equal inverse cotangent of x over 3. We'll do the same over here. Cotangent A plus theta equals x over 10. A plus theta equals inverse cotangent x over 10. And then what we can do is plug in this A for this one and then solve for the other side. And what we get is theta equals inverse cotangent x over 10 minus inverse cotangent x over 3. Then we want to remember that our inverse to find the derivative of the inverse cotangent, it's negative 1 over 1 plus x squared. And we want to go ahead and find that. And we're going to use chain rule to find that. So we're going to plug in x over 10 and x over 3. So this will be negative 1 over 1 plus x over 10 squared times the derivative of x over 10 times the derivative of x in relation to time, minus negative 1 over 1 plus x over 3 squared times the derivative of x over 3 times the derivative of x in relation to t, or time. We're going to solve and simplify all that, and we end up with negative 10 x prime, or derivative of x in relation to time, over 100 plus x squared, plus, because these two negatives are going to make a positive, 3 x prime over 9 plus x squared. So this is our derivative for theta. So once we have that, then we need to just plug in our x and our x derivative, which was given to us in that x was 30 and the derivative of x was 3 feet per second. Because we're moving away at 3 feet per second, and we want to know how much the angle is changing when we're at 30 feet away. So then we just plug in the 3 and the 30, and we solve. So that would equal negative 0.02009. So as we walk away from the screen, the angle is changing at a negative 0.02009 radians per second. Thank you. I hope this was informative.